All right, so what you're going to look at here is how to do Lewis structures for covalent compounds. Remember, Lewis was the guy that looked at valence electrons, and he made Lewis dot diagrams. These are sort of a similar idea to that. You're looking at covalent compounds. You'll know it's covalent because you have two nonmetals being put together. And what every single nonmetal is trying to do in the compound is it's trying to share electrons to give it what it wants. And what it wants almost all the time is you want to make sure in your Lewis dot diagram everyone has 8, except for hydrogen. Hydrogen wants only 2 because it's in that first energy level, so 2 is full in the first energy level. But for the most part, what you're going to do at the end is you're going to look at your picture and make sure everyone has 8. And I'll show you sort of the dotty way of doing it. We're going to do them a little bit more like formulaic. But so chlorine, for instance, is in group 7. It's a halogen. So if I did a Lewis dot for that, it would have 7 dots. And that's one chlorine. This is Cl2, so there would be another chlorine, Cl. 7 dots. And what could happen, so this chlorine's got 7. This chlorine's got 7. They both want 8. So what they do is they say, okay, well, why don't we share these two, right? And if I shared those two in the middle between us, then this one has 8 around it, and this one has 8 around it, and we have this shared part in the middle that's 2 shared electrons. And when you have 2 shared electrons, that is a covalent bond. And the way you show a covalent bond, the actual Lewis structure for that would be Cl bonded to Cl. That's those 2 here. Make a line. You turn the 2 shared dots into a bond. And then they still have 6 dots of their own. And again, this thing is shared between the 2, and it counts as 2. So 2, 4, 6, 8. 2, 4, 6, 8, and everyone has 8, which is what it should look like. Here's how I do it, and I'll walk you through an example as I go. I do it sort of formulaically. The first thing you do is you draw the atoms. So I'm going to look at CH4 all the way through. The rule is you have a central atom that goes in the middle, and the central atom is the one you have the least of. So here I have 1 carbon and 4 hydrogens. I have less carbons, so carbon is going to go in the middle. Hydrogens around it. 2, 3, 4. I'll just put 1 on each side. So I picked carbon for the middle because I had only 1 carbon, so it goes in the middle. If you have a tie, you only have like 1 of each of them, then you look for the least electronegative. That's the furthest from fluorine, because fluorine is the most electronegative. And then we're good. So here's what I have so far for my Lewis picture. I've got a C with 4 H's around it. I'm just going to redraw that here. Okay? The next step you need to do is you need to look at your formula. Our formula is CH4, and figure out its total number of valence electrons. So I go to my periodic table and I look up carbon. Carbon has 4 valence electrons. And then I have 4 hydrogens. Each hydrogen is in group 1. So each hydrogen has 1 valence electron, and I have 4 of them. Only got 1 carbon, so it would be 1 times 4. 4 plus 4 tells me that I have 8 electrons that I want to put in my picture. So I just added up my valence electrons, and what this says, I'm going to add up my valence electrons, and that's how many I'm going to have to draw in. I'm going to have to put in 8 in my picture. The next thing you do is you bond. There's James Bond. So I have C, I have H's, and I know that I have 8 valence electrons to put in my picture. So the first thing you do is everything has to get bonded to this C, right? And remember, a bond is 2 electrons. It's a shared pair of electrons. So I go bond, 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 bond. That's 1, 2, 3, 4 bonds. Each bond gives me 2, so I just used 8, which takes me to 0. I like 0. That's where I have to end up every time. I have to put all 8 in. And then the next thing I would do is I would fix the outer atoms. That's step 4. Make sure you're writing these steps down. So I would fix the outer ones. Hydrogen wants 2, and it's got a bond, so it has 2. So that one's good, that one's good, that one's good, that one's good. There is no fix for an outer atom this time. And then the final step is to fix your central atom. Make sure it's got the 8 that it needs. And I look, it has 2, 4, 6, 8. It's good. So this is the Lewis structure for CH4. Just C with 4 bonds to H's. Hopefully okay. I have several more examples here. Right? So I just left the steps here as a reminder, and we'll walk through. The first thing you do is you draw the atoms. I have 1 silicon. I've got 4 bromines. So silicon goes in the middle, and Brs around it. 1, 2, 3, 4. Good. Count your valence electrons. Silicon gives me 4. I have 4 bromines. Each of those, and hopefully you're looking on your periodic table, they're in group 7. So I have 7 valence electrons. 4 plus, this gives me 28. 4 and 28 get me 32. So now I have 32 things to put in this picture. First thing I do is I bond, 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 bond. That's 2, 4, 6, 8 electrons that I just put in bonds, leaving me with 24 left over. So that's step 3. Step 4, fix the outer ones. Bromine is not hydrogen, so bromine doesn't want 2, it wants 8. And right now this one has 2 from this bond, so I need to give it 6 more. This bromine has 2, 6 more to get 8. 2, 6 more. 2, 6 more. And I just put in 6, 12, 18, 24 dots. Takes me to 0. You're not done yet. Check your middle one. Your middle one has to have 8. Right now it has 2, 4, 6, 8. And that's a beautiful thing. I'm at 0, and everyone has what they want. That is a correct Lewis structure. Next one, PCl3, same idea, only 1 phosphorus, so it's in the middle. Cl, 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 3 of them. Draw the atoms is good. Count your valence electrons. Phosphorus gives me 5 plus 3 chlorines. Each of those gives me 7. Group 5, 5. Group 7, 7. 5 plus 21 is 26. Okay. Bond, bond, bond. 2, 4, 6 leaves me with 20. Good. Fix the outer ones. This chlorine has 2. It needs 8. So I got to give it 6 more. Notice you'll always give things 6 more on the outside unless they are hydrogen. 6 more here. 6 more here. Gets me 6, 12, 18 of them. And what that gives me is that gives me 2 left over. And I have to use all 26, and I have 2 left over. And I go, shoot, I have 2 left over, but the outer ones are already fine. Well, then you fix the middle one, and what I could do, phosphorus right now has 2, 4, 6, so it could use that extra 2, and I put it on the central atom right there. And then it has 2, 4, 6, 8. And I also used my 2, which gets me to 0. And that's significant. If you have an extra pair on the central atom, they call that a lone pair of electrons. It is just a pair sitting by itself. That's called a lone pair. Get it? Lone pair. So that's what you get there. And it will change the shape once we start looking at the shape. But in order to get it, our 8, we take our extra 2. If you ever have extras, they go on the central atom. So I've added that to the steps now. If you have fixed your outer atoms and you still have extras, those are going to go on the central atom as lone pairs. And we'll do it again. Hydrogen 2, oxygen 1. I have less oxygens, so oxygen in the middle with an H and an H. Okay. Number of valence electrons. 2 hydrogens. Hydrogen's in group 1, so it has 1 valence, plus 1 oxygen. Oxygen in group 6. 2 and 6 is 8. Bond. Bond, bond. That's 2, 4. Leaves me with 4. Fix the outer atoms. That's hydrogen. And hydrogen, I go, ha, hydrogen. You only want 2. So it's 2 and 2. That's good. Those are already set, which leaves me with 4 extras. So I put 2 of them as a lone pair, and another 2 of them as a lone pair that has 2 lone pairs on the O. But that gets me 2, 4, 6, 8 of them, and we're good. These are fun. The next possibility, something else could happen, and it happens in SO3. Same process to start with. I have less sulfurs, so I'm going to put sulfur in the middle. Oops. Ignore. Bloop. Sorry about that. Sulfur, oxygen, oxygen, oxygen. Count my valence. Sulfur's in group 6. I have 3 oxygens. That's also in group 6. 6 plus 18 tells me my picture needs 24. Okay, so I'm going to bond, bond, bond. That's 2, 4, 6 of them. Leaves me with 18. 6 on the outside because it's not hydrogen. 6 more. 6 more. 18 takes me to 0, and I go, all right, I'm at 0. Here's the problem. Stop clicking. I look at my central atom, and it has 2, 4, 6. And I go, uh-oh. Because I don't have extras, I cannot put a lone pair on that. If I don't have extras to use, I can't have a lone pair. So I'm in trouble here. And what you can do instead is you say, okay, I gave this oxygen what it needed, I gave this oxygen what it needed, I gave this oxygen what it needed, but I'm going to have to get one of those oxygens, and I can take this, instead of giving it the 8, I could say, well, these 2 instead of just giving it to the oxygen, I could share that again. And then that gets me 2, 4, 6, 8 on the sulfur, and still 2, 4, 6, 8 on the oxygen. And that's called, wait for it, a double bond. Oh boy. If you run out and the middle does not have 8, that's when you have to multiple bond. The other thing that happens that makes this unique is that I put that double bond on the sulfur and oxygen bond going to the left. I didn't necessarily have to do that. That's weird. I could have put it here. Or here. Or here. And since you could put it in 3 places, you get something called resonance. And resonance says that if you have a multiple bond, there is an equal probability that it could end up in any place around the central atom. So the fun, well, it's not really that fun, but you have to do it. If there's a possibility for that it could be in a different place, you have to draw it in that place. So I drew it like this, with the double bond to the left. I wouldn't have had to. It also could have, I could have put it on the top with 4 more and had these with 6. I could have shared up top instead. Or I could have put it off to the right and the correct answer is that you have to draw all of those. If you have a double bond, you have to show resonance, so you have to draw all 3 of those guys. Yuck. And I added that rule there. If your count is at 0 and the middle one still doesn't have 8, then you have to multiple bond. So here's what we've got. SeO2, 1 Se, 2 O's, so Se in the middle. Se gives me 6 plus 2 oxygens. Those are in group 6 also. Tells me to put in 18. Bond and bond, that uses 4. Leaves me with 14. Fix the outside, 6. 6. 6 and 6 is 12, leaves me with 2. And that's extras. Extras equal lone pairs. So I put a lone pair on there, uses up my 2, takes me to 0. I still have to check the middle. Does the middle have 8? It has 2, 4, 6, and I go, oh shoot, doesn't have 8. If I'm at 0 and I still don't have 8, I need a multiple bond. So I'm going to take 2 away from this oxygen and double bond. So this has a lone pair and a double bond. Except I didn't necessarily have to pick the one on the left. I also could have picked the one on the right. That's 2, 4, 6, 8. 2, 4, 6, 8. So I show resonance for that also. Whew. One last possibility, and then we will spend all of tomorrow, and you can ask as many questions as you want and work on this and get better at it. SF6 is another sort of situation that can happen. I have an S. I have 6 F's to put around it. What are you doing? F. Stop it. F. 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 count. Sulfur gives me 6. It's in group 6. Plus 6 times 7, because fluorine's in group 7. 6 and 42 says put in 48. Ugh. Bond, 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 bond. They all have to have a bond. So that's 2, 4, 6, 8, 12. Leaves me with 36. 6 and 6 and 6 and 6 and 6 and 6 to get 8 on all of those, and that's 6, 6, 6, 6, 6, 6. There are 6 6s. 6 times 6 is 36, which takes me to 0. You're not done. Make sure the middle is good. So I count the middle and I go 2, 4, 6, 8, 10, 12. It's got 12. And so in this case, there are 12 around the middle. You have 12 on your central atom, which is more than 8. And as long as it's more than 8, you're good. What you get sometimes is you get something called an expanded octet. And what you can do is on many elements, if they're in the 3rd period or below, because we need d orbitals to do it, and the d's start at 3d. So as long as you're in the 3rd period or below, so just not boron, carbon, nitrogen, oxygen, fluorine, neon, that's the 2nd period. The row below that or down, you can go expanded. And what you can do, that means, is the middle can have more than 8. Doesn't matter how many it has, really. You have to put all of the ones in. So in this picture, we had to put in 48. We had 6 things bonded to it, so it's going to have 12. But you can bond to it either 5 or 6 times. If you still have extras, you just chuck them on the middle. Things could go expanded if you need them to. So quick summary, and then I'm done until you come in tomorrow. You do all your work. You fix your outsides, 8 except for hydrogen. Remember, your bonds are 2. And then you fix your central atom. And there's 3 really things that could happen. If you have extras in your count, you're not at 0 yet. Those go on the central atom as lone pairs. If you make it to 0, and your middle still doesn't have 8, then you need a multiple bond. If it has more than 8, that's okay. It just means it's expanded. Hopefully that was okay. Rewatch things if you need to, and we will spend all of tomorrow looking at that. See you soon.